Now let us see the exercise 2.4. Now question number 1. Determine which of the following polynomials has x plus 1 a factor. Now here 4 polynomials are given and we have to check x minus 1 is a factor of which polynomial. How to check? If by putting x is equal to minus 1, because we have to find the 0 of this given linear polynomial, that is equal to x is equal to minus 1. By putting this x is equal to minus 1 in this given polynomials, if that value of p of minus 1 is equal to 0, then this is the factor of the given polynomial. So I am going to explain first and fourth sum here. The remaining two sums, second and third, are for homework. Now the first sum, question number 1. The given polynomial is p of x is equal to x cube plus x square plus x plus 1. On putting x plus 1 is equal to 0, that is x is equal to minus 1, in the polynomial, given polynomial, we get p of minus 1 is equal to 0 here. We know that minus 1 cube is minus 1, minus 1 square is plus 1, this minus 1 and this plus 1 gives 0. Hence, as the p of minus 1 is 0, x plus 1 is a factor of p of x. This is by factor theorem. Now fourth sum, the given polynomial is x cube minus x square minus in bracket 2 plus root 2 into x plus root 2. Now putting x minus 1, x is equal to minus 1 in this polynomial, we get p of minus 1 is equal to minus 1 cube minus into bracket minus 1 square minus into bracket 2 plus root 2 into minus 1 plus root 2. Now this calculation gives p of minus 1 is equal to 2 root 2. Because here minus 1 cube is minus 1, minus 1 square is plus 1, this minus, because of this minus sign, this minus 1. Then because of this minus sign, the signs of the terms inside the bracket are going to change. So this going to change, but again this is multiplied by minus 1. So this is this minus 1 and this minus sign gives the plus sign here again. So this remains as it is. So minus minus becomes plus. So 2 plus root 2 and this plus root 2. Now here minus 1 minus 1 gives minus 2. This plus 2 and this root 2 plus root 2 is 2 root 2. Now this minus plus get cancelled and remains 2 root 2. As this p of minus 1 is not equal to 0, x plus 1 is not a factor of p of x. Similarly, question number 2. Here given polynomial is p of x is equal to 2x cube plus x square minus 2x minus 1 and g of x is equal to x plus 1. Now 0 of g of x is, that means x plus 1 is equal to 0 gives x is equal to minus 1. On putting this x is equal to minus 1 in p of x, we get p of minus 1 is equal to 2 into bracket minus 1 cube plus minus 1 square minus 2 into minus 1 minus 1. This gives p of minus 1 is equal to 0. As p of minus 1 is equal to 0, g of x, that means the x plus 1 is a factor of p of x. Again this is by factor theorem. Thus now question number 2, first sum we have solved now. Here you have to show that g of x, given g of x is a factor of p of x or not. Now next these two sums are for homework. Now let us start question number 3. Find the value of k if x minus 1 is a factor of p of x in each of the following cases. Now here four polynomials are given. We have to find the value of k, that is the unknown, if x minus 1 is a factor of p of x. This is given. That means x minus 1 is a factor of p of x of each polynomial here. then we have to find the value of this unknown. Now let us start solving the sum. The first sum is, here x minus 1 is a factor of p of x and p of x is equal to x square plus x plus k. Now we have to find the value of k. Now take the 0 of this factor, that is x is equal to 1, and put this value in p of x. So as it is a factor, our remainder is 0. That means p of 1 is equal to 0. By putting the value of x in the polynomial, it is 0. That is p of 1 is 0. Therefore, what is p of 1? By putting 1 in this given polynomial. So 1 square plus 1 plus k is equal to 0. Now here 1 square is 1, 1 plus 1, 2, 2 plus k is equal to 0, and therefore k is equal to minus 2. Thus we have find the value of k here by using the factor theorem. Now the third sum, second and fourth are for homework. Third sum I am going to explain here. The given polynomial is kx square minus root 2x plus 1. Here again x minus 1 is a factor of p of x which is given, and therefore p of 1, because its 0 is x is equal to 1, and by putting that value of x in the given polynomial we will get p of 1 which is equal to 0, because this x minus 1 is a factor which is given. Now find the p of 1 here and equate it equal to the 0 and equate it with 0. So k into 1 square, k into 1 square minus root 2 into 1 plus 1 is equal to 0. 1 square is 1, k into 1 is k, minus root 2 plus 1 is equal to 0. Therefore k is equal to, now we are going to take all these two terms on this side. So this plus 1 becomes minus 1 and minus root 2 becomes plus root 2. So k is equal to root 2 minus 1. Now question number 4 is factorize. Here 4 quadratic polynomials are given. We have to solve these 4 quadratic polynomials, or we have to factorize these quadratic polynomials by using the splitting the middle term method, which we have learned in the 8th standard. Now I am going to explain here one sum, others you have to solve yourself. Let us start the first sum here. Given that p of x is equal to 12x square minus 7x plus 1. This is the given quadratic polynomial. Now using the splitting the middle term method, we have to factorize. Now this 12 into 1 is 12. Now this is the constant term here. We have to factorize it. Factors of 12 are 3 and 4. 3 4s are 12. Now we have to decide the signs of these factors. Here we want 12 as plus. So minus 3 into minus 4 is equal to plus 12. And the middle term we want minus 7. So minus 3 minus 4 is minus 7. So these are the correct factors. Now write down 12x square minus 3x minus 4x plus 1. So we have splitted this middle term here. Now next step, from the first two terms you can take 3x common. So 4x minus 1 remains inside the bracket, minus the next, from the next two terms you can take 1 common. So in bracket, so minus 1 common, and in bracket you will get 4x minus 1. Now this 4x minus 1, this bracket is common, so you can take that bracket common and you will get 3x minus 1 in the second bracket. Now these are the factors of the given polynomial. Now let us start question number 5. As I have explained the first sum before, I am going to explain fourth sum now. Now here the given polynomial is in the variable y. So p of y is equal to 2y cube plus y square minus 2y minus 1. Now here no need to use the factor theorem, because if you can observe, we can take the common term from the first two terms. So we will get here, if we will take y square as common, we will get in the bracket 2y plus 1. Now here you can take minus 1 common from the next two terms. You will get here minus 1 in bracket 2y plus 1. Because of this minus sign outside the bracket, the signs of the terms in the bracket are going to change. So this minus 2y becomes plus 2y and minus 1 becomes plus 1. Now this bracket you can take common as these are the two terms and 2y plus 1 is common in between these two. So write down 2y plus 1 into another bracket y square minus 1. So this bracket common, so y square from the first term and minus 1 from the second term. Now here again this is a quadratic polynomial, we have to factorize it. Now we have the identity that we have learned in last year, that is a square minus b square is equal to a plus b into a minus b. So we can use that identity and we can factorize this bracket. So 2y plus 1 keep as it is, and here a is y. So y plus 1 and y minus 1 are the factors of this bracket. So these are the three factors of this given cubic polynomial. You can use this method also for factorizing the given polynomials. Now here we have completed the exercise 2.4. The other remaining sums which I have not explained here in the video, you have to solve those. Question number 5, all sums, the solutions I am going to send you. But from other sums you have to solve the sums yourself.